In aqueous solution, ammonia reacts as NH3 aqueous plus H2O liquid yields to NH4 plus aqueous plus OH minus aqueous. In a 0.018 molarity NH3 solution at 25 degrees Celsius, the hydroxide ion concentration is 5.6 times 10 to the negative 4 molarity. Temperature is constant at 25 degrees Celsius and the volumes are additive. For part A, we need to write the equilibrium constant expression for the reaction. So K is equal to the concentration of NH4 plus times the concentration of OH minus over the concentration of NH3. Part B is to determine the pH of a 0.018 molarity NH3 solution. We are given the concentration of OH ion, which is 5.6 times 10 negative 4. With this, we can find the pOH by taking the negative log of the OH ion concentration. The pOH is 3.252. Because the sum of pH and pOH equals 14, 3.252 is subtracted from 14 to find the pH of NH3. Therefore, the pH is 10.748. In part C, we need to determine the value of the base ionization constant, Kb of NH3. To solve, we set up an icebox using the previously given equation. Liquids and solids do not affect Kb, so H2O is not included in the icebox. We can fill in portions of the icebox with what we are given and what we can infer. The initial concentration of NH3 is 0.018 molarity, while we have no NH4 plus and OH minus to begin with. We also know that the concentration of OH minus at equilibrium is 5.6 times 10 to the negative 4, and therefore the concentration of NH4 is also 5.6 times 10 to the negative 4 because they are both X. The concentration of NH3 at equilibrium is the equation 0.0180 minus X, and because we know that X is 5.6 times negative 4, we can plug that into the equation to get 0.01744 for NH3 at equilibrium. After, we can plug in the equilibrium values into the equilibrium expression. So we have K is equal to 5.6 times 10 to the negative 4 to the second power over 0.01744. And after solving, we get 1.8 times 10 to the negative 5 for Kb. Part D is to determine the percent ionization of NH3 in 0.018 molarity NH3 solution. The equation for percent ionization is concentration at equilibrium divided by initial concentration times 100. Using our data, we can plug in 5.6 times 10 to the negative 4 over 0.018 and multiply that by 100 to find the percent ionization, which equals 3.11%.